This is TWiT.
I'm seeing a lot of positive press about this NPU thing, and Qualcomm's next. And The Verge said yesterday, Microsoft wants to beat Apple at the
Who cares what
game.
Microsoft or The Verge says? What I say
What
is...
does Paul Thurrott say?
What is Paul?
Microsoft said something, marketing about Windows. That's interesting.
No, yeah.
You know what's more interesting is someone who looks at it themselves and says, actually, this thing's pretty damn good.
Mm-hmm. Is it? Are you excited?
Yeah, it really, yeah.
So you took this thing out for a spin.
Well, I took it in for a spin. I couldn't take it anywhere, but it was Qualcomm has started inviting the press to kind of see for themselves like what these things are like ahead of the release of actual hardware. So it's Qualcomm, you don't get to hear about like which companies are doing what and when and that kind of stuff. So those announcements will come, but they have their own reference hardware. And some interesting stuff came out of that. I mean, I just qualify it by saying, there's always that little kind of gotcha that may or may not happen. We'll see. But, it's one thing to be in a room with a bunch of these computers and be able to play with them and do whatever you want to do. But, I mean, obviously you have to get an actual hardware from computer from Dell or Lenovo or HP or whatever and see what those are like in the real world. But what I saw that day was nothing but impressive, like really impressive.
And so it seems to
Did
be
it feel overbuilt, like they're really building a crazy high-end machine, or you never know with reference hardware?
Yep.
Oh, so this is not from, this is not like the latest Dell. This is a Qualcomm build.
Yeah, these were Qualcomm
reference
computers. They had, depending on the machine, it had 16, 32, or 64 gigs of RAM. LP, DDR5X, right? So it's fast, good SSDs. They were just 1080p screens, nothing special there. But yeah, running, the X Elite processor, which has the integrated CPU, GPU, and NPU. And then
you got to call it an M1 competitor, right? I mean, that's what you're describing.
That's what they're aiming at, isn't it?
It's an M3 competitor, actually, right? I mean, it's these things are not neck to neck, but in every category. I think the way it works out is that single core, I think the M3 is a little ahead, and multi-core, the Qualcomm is ahead, that kind of thing. But like I said, this is going to come down to actual real world software running on real world PCs. And also, what's the battery life like, right? We don't know that, but the thing that's the interesting framing bit for me is I've been using this MacBook Air lately, and it is super thin, very light for the size of the screen. It has no fans, makes no noise. It never heats up. It never gets overloaded. It never glitches or acts weird or does anything strange. And, sitting in that room with these computers and playing some games and running some AI stuff. And this is a pretty funny video. That might be worth playing. But there were some good demos. And one of them was, a lot of them speak to this question we've had, which is, okay, but what are the apps? Like, how are we going to use this thing in the real world? Like, how do we sell this on people? What's the elevator pitch or whatever, one of the better demos, well, that's not really, one of the demos was Audacity is using the NPU to do real-time song creation based on a text prompt, right?
Okay. That sounds horrible.
Stable Diffusion, obviously. There was video editing with DaVinci Resolve, which is using the NPU across a variety of workloads, that type of stuff. The games you're seeing here in this video are emulated. These are x64 games. They're desktop apps. They're from Epic, not from the Microsoft Store.
Wow. So this is worst case scenario.
Yeah. I mean, and this is, see, before I saw this, what I would have said to you, like, what are these chips targeting? I would have said mainstream ultrabook.
Yeah.
And
my reaction to seeing games being played is like, what? Why are we looking at games?
Because that stretches the limits of, what's possible, right? So the other video, Leo, is actually kind of humorous, only because I make a joke at the end of it that was just perfectly timed. But the other one is like is the music creation demo video. It's probably just 12 or 15 seconds long, but I don't know if we can play it on
the same article or?
It's in the article. Yeah, if you scroll down, you'll see it in the middle of the article.
Okay. Still scrolling.
I just want to see, like, what do you pin the NPU with, right? Like, I love your screenshot there where the NPU is running like,
just like getting cranked. Yeah, exactly.
That's what you want, right? Tell me you're using this.
9 seconds here. We got 5 minutes of. Here we go.
5 seconds.
It created every Nickelback song. So I'm unduly proud of that one. But anyway, look, I would say since last October when they announced this chipset, there has been a lot of rumors and leaked benchmark stuff, and it's all been very positive, and nothing I saw did anything but verify that kind of stuff.
Yeah,
right?
This is what this is what Qualcomm promised last year at their event, and of course, my reaction was the sensible one.
You've lied to us before.
Well, let's wait and see. But now we've waited, and we're seeing the only.
It's like you've been punched in the face repeatedly, and the guy standing there with his fist like this. He's like, "No, this time I'm not going to punch you." And you're like,
I wish I could get it in this red, though. I tell you what, I forget the performance and all that. I just want the red color of that. That's beautiful. That's AMD's color, though. Somebody better tell Qualcomm.
So one interesting thing that I noticed there, and others noticed too. I shouldn't pretend this was like an original thought or anything, but Qualcomm wouldn't talk about this too much. But there are different versions of this chip in those computers. Some people were reporting it as 2. I think I saw 3 different versions, and they have different kind of model numbers and different. They have the same core. The NPU is the same always. Sometimes it's not clear like what the differences were, but there is some sort of hierarchy or tiering of the chipset. So the only thing they said they said basically, look, we're not going to talk about this, but the one thing we can promise you is that unlike certain companies, we're not going to over skew it. Like in other words, we're not going to have 1 million processor versions like say Intel does. So we'll see what that means, but I thought that was kind of interesting.
So they're all Orion core, right? That's the code name, ORYON, but they're different.
Yeah.
There's different, there are multiple SKUs. This is running.
They're different configurations,
which is really interesting. That's fast.
Yeah, there was
really high.
The one was higher than that actually, and then there was a 3-point something. But the other thing is, and again, I'm not a hardware guy. I have to keep qualifying these things. Companies can handle this multi-core, performant core, efficient core thing differently, right? So Intel, as they move into this kind of hybrid architecture with the Core Ultra chipsets in particular, have 3 types of cores, right? There's performant cores, efficient cores, and high efficient core, or ultra, whatever the term is. And the idea is you can turn these things on or off as needed. And ideally, what you have is a computer sitting there doing nothing, and all the cores are off, but maybe 1 or 2 of the high efficiency cores are just sitting there doing background processes or something like that. And it's efficient, right? Apple has 2, is that true? I think Apple has 2 kinds of cores, right? Yeah. And AMD, the one-off kind of chipset they did before they started moving everything over to this hybrid architecture, the way their cores worked for this was like in the HP Dragonfly Pro, I think is the name of it. Whatever number of cores it had, they could turn them on and off arbitrarily, but also vary the amount of power they receive. So that's another way to kind of handle performance, efficiency, et cetera. So these Qualcomm chipsets, or this Qualcomm chipset, has only 1 type of core.
Yeah, I
multiple
think
cores.
You're really talking about how Intel compensates for the fact that their pipelines are too complicated, and they're just afraid to get away from that. So they've gone this multiple different strategies to try
it's
reduce
right.
power consumption. Where if we just were simpler in the first place, what if there was one kind of core that was power efficient and performant? What a concept.
Why can't the 1 core do it all? Yeah, so that's why I think the AMD approach is kind of interesting, because it's mimicking how at least Qualcomm does things, so, in the ARM space.
I would argue that's a byproduct of ARM more than it's a byproduct of what Qualcomm did with it.
Okay. Yeah. Okay. I don't know. Like I said, I'm not really a hardcore. It's just, I don't.
Would you like a 20-minute on CPU architecture? Like, we can do that. I don't think you want it.
I don't. I'm just. I bring it up only because I found it interesting, and I don't want anyone to think I'm presenting myself as some kind of an expert. Like, this system is better, because it's not that. It's just different. It's interesting to me that it's different.
Yeah.
And we'll see.
It's part of there's a keynote I do where I talk about the hardware problems and in relation to Moore's Law, and I show the logic diagram of a modern Intel CPU beside the logic diagram of a modern ARM chip. I think it's like the A8 or something like that. And it's just because they've continuously built on it and built on it and built on it. There's just so many different little subsystems all through the CPU that they're afraid to move. Every time they try to move away from it, they've been hammered by it, right? Like, their customers have always been angry with them for it. And
well, so they are the hardware version of Microsoft. They can't get away from the backwards compat thing, you know?
Yeah, they have the innovator's dilemma by times 1,000, right?
Yeah. There's I know that when Apple was designing the M series chips, one of the modifications they made, and it was kind of in deference to the legacy code base, right? That on the Mac, just like on Windows, it was Intel based, right, at that time. They did something to allow for a quick conversion of those different architectures specifically for emulated code, right? Which went a long way, apparently, to making those things more efficient to that kind of thing, and is one of those things that just helped the Mac be very successful in that transition, right? You know, whereas, you know, I don't know how they, again, not a hardware guy, but I look back at something like Windows RT, which was our initial attempt in the Windows space to go to ARM. And, you know, we got it to compile and everything, you know, but it could not emulate, like emulating.
The advantage that Apple has is the walled garden. It's their hardware. It's their OS. It's their core apps. They're used to beating their developers to death anyway. So that, you know, they don't, it's like, hey, we changed chipset. You need to fix your apps or you don't get to ship. Like, that's how it is.
There is it's not worth debating, but the different approaches of Microsoft and Apple when it comes to backward compatibility, the more aggressive way that Apple obsoletes technology and moves forward, right, has its advantages. It has its disadvantages. I mean, I think, you know, in the Windows space, one of the reasons why, or in the PC space, you know, one of the reasons why Windows is such a big deal for enterprises, I think, and they want that stability, and they want to know that you don't have to think about it. Everything's going to work always. You know, they
want a 10-year machine that doesn't need to have anything changed, and it'll work for 10 years.
Yep. And Microsoft is, you know, they deliver that. And I always felt like maybe there was a happy medium that could be found, but I will
argue, like, what's the argument for these Qualcomm machines? It's not necessarily Windows so much as it's less expensive Mac-like computers. Apple never tries to go for the low margin devices. That's not their business, right? They're they're the luxury product, and they price accordingly.
I want to be careful. I'm not throwing a PC company under or a bus or anything. I don't mean it like this, but it is just a weird coincidence that the other night, I told the story to Brad this morning, but I got a new computer to review, and I'm setting it up. We're watching TV, my wife and I, in the dark there, and I'm just doing all the initial setup stuff, right? And so it has to install updates. It has to install app updates. It reboots and it installs a firmware update. And as it's doing that, the machine, this is the sound that went on for 15 minutes. You know,
sounds like
the fan noise out of the thing. 2 seconds in, my wife looks up. She's like, "What are you doing?" And I'm like, I don't know. It's updating the firmware. So, you know, this is as modern of a PC as you can get. It has a Core Ultra, whatever, 155H, whatever it is, processor. And I'm looking over at this MacBook Air, which has no fans, right? Yeah. And is super efficient and gets literally 24 hours, well, literally probably 18 hours of battery life or whatever it is. And I'm thinking to myself, we can't get to that quick enough in the Windows space. Like, it's so important. And this is the thing, you know.
And you got to know that there's a safety mechanism in that machine that when it's changing the firmware that would normally vary the fan speed, default all fans to max until the firmware's back.
Oh, that's good.
Yeah.
Right? Otherwise, you could damage the machine.
But,
well, I'm glad the machine's safe. I just,
but it ruined it ruined your viewing of Friends. But what are you going to do?
Don't update firmware while you're watching TV.
Friends.
Yeah.
But
Is this
I was going to
matter?
say everybody loves Raymond.
Does this matter for desktops? Are we still going to want to use Intel on the desktop and just Qualcomm Elite for?
Yeah.
So the two things that are going. So it's funny because Richard asked a question that was, I think, is related to this up front, which was like, what's the market these things target? And like I said, I, in the beginning, I before last week, I would have assumed it's solely ultra thin, ultra light, portable laptops, right?
Yeah.
Business class laptops, right? And there's no doubt that's a big part of the push. This is the kind of, the MacBook Air part, mainstream part of the market, right? It's where most PCs are sold. But it seems like it's better than that. So it could be.
I think it is too.
It has kind of a tiered experience, maybe. So it could. I'm not saying it's a gaming PC, but it's maybe more than, it's more than just that center part of the market. So that's interesting.
I think that the race right now is who establishes the NPU standard.
Yeah.
This is the race. And you have to do it with hardware. You have to.
Yep. We're gonna talk about this a little bit. I want to get to the Intel stuff in a second because this plays
the thing
into
is,
that,
like, Apple should win this, except they missed the AI ride.
So let's see what happens. We're 2 months, what is it, 3 months away from WWDC. I'm really curious to see what they come out of the gate with, because they are also going to follow Google and Microsoft with their respective developer shows. So this is the next, this is why I had this up front. The next few months are just an inflection point almost in the industry. It's very, very interesting.
This is when the NPU standard gets declared. What are we going to build against?
Yep. But with regards to desktop computers or, workstation class computers or gaming computers, that kind of thing, I think that there are two things going on. One is that ARM is scaling up, obviously, and we'll see how the companies that actually provide ARM chipsets adapt or don't adapt to the needs of that market, like like bigger, beefier GPUs in particular, what it happens or not. Or on the Intel x86, whatever side, we'll see hybrid designs that kind of mimic the ARM architecture, or maybe one day adopt it.
Right.
Or maybe it's that car truck thing that Steve Jobs talked about. I mean, at some point, that part of the market becomes a smaller and smaller, still important, but kind of subset of the market for those, I'm going to call them vertical use cases, right? Gamers, workstations, et cetera, et cetera.
Yeah.
I don't know. I mean, we'll see how it evolves.
I would also argue here that this is weird. If Microsoft wins this, it's almost unprecedented. I mean, Microsoft is used to building the API that makes all the stacks work together, right? The normal pattern for this should have been Apple wins it or Google wins it, the others emulate it, and then Microsoft comes in third with an API that allows all of them to work together. If Microsoft comes in first here and somebody else has to make, think ODBC, right? Microsoft did not have a winning database, and so they created an database. They
abstracted the connection. Who cares what the database is? Yeah,
precisely. And here's the issue, Paul.
Yeah,
it's not just that Microsoft can do that; it's that the rest of them largely can't. Like that whole approach to iterating on a standardized interface for developers.
Right.
I mean, Google can. They'll just drop it 3 times along the way until nobody's willing to use it. And Apple wants 30%.
There's something happening, and it's not a thing, it's a bunch of things, but a lot of it has to do with AI and NPUs and all this stuff. We've talked about these automatic upscalers that are coming, that are already here from various video card makers and are coming to Windows. This notion that you can, I think to date, the argument was, look, you have to have the beefiest possible hardware to run this thing at the best possible quality and resolution and frame rate. And you can't beat the physics of it, but you can sort of beat the physics of it by emulating it to the point where for most people, it doesn't matter.
Yeah.
And you enable higher quality seeming games, if you will, to be run on lesser quality hardware, for lack of a better term.
8K TVs aren't taking off for a reason. Most people can see the difference.
Yeah,
so imagine if everything is upscaled to at least HD, and it's going to be good enough.
Yep. And
this is the real destination of augmented reality. What if we just made your world shiny?
I mean, the applications here are incredible. I mean, if you to keep it to a very kind of niche-y kind of thing, you go back, you're like, I want to look at like an old video from like an Apple keynote from the 1990s or an old Microsoft event, and it's this 320 by 240, 15 frames a second piece of garbage. And what if things like that could be upscaled? And that stuff's not really historically that important, but then you can apply it to things that are important and more meaningful, or to TV shows that were not filmed in HD during that horrible era between film and HD, where everything was made on videotape and it was low quality.
Yeah.
There's a whole, and that's just video, right? I mean, but there's a whole world of content out there that can benefit from this stuff, and things get a new lease on life. You know, I talk about playing old video games all the time, like the original Halo.
And the question is that game still good if it's
Half-Life?
If it's in high def?
Yeah, well, I can tell you that Half-Life is. The first one is, absolutely. I mean, not all, not all of them for sure.
Hey, it's me, Leo Laporte. I hope you've enjoyed this little snippet from Windows Weekly. If you want to see more, want to catch the whole show, you can subscribe in your favorite podcast client or visit our website, twit.tv/WW. And of course, there's links right below me.